Hi, this is Bill Foote. It's Stats 1, and it's still Lecture 8. And this is really Part 4. And what we're going to do in this lecture, well, really demonstration, is to take the sample that we built out of Part 3. See, it's a RAM between 1 to 4. And between 1 and 6. So those are the rows and the columns, the 4 columns and the 6 rows, to pull out a sample from each of the 24 of these. So we have 24 There we go. So this is where we had gotten to before, and we'd also had made a major calculation based upon this sample over here. This is our standard Gaussian machine. You can see we're using norm.dist. We have 22 hypotheses. The first 11 are for the low sigma environment, and the second 11, same mu's, same means for the that are fed into the Gaussian beast over here in a high volatility environment. Our whole job is to come up with this final column which says how likely or how plausible is each hypothesis, those pairs of mu's and sigmas. And this is very much less plausible. You can see here the first one relative to the second, relative to the third, fourth, and the fifth, and the sixth one, however, is the most plausible. Absolutely the most plausible. It looks like it's right in the middle of things as well. And seventh, down, 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 down. You can see how this just declines into the 11th hypothesis. And the same in the high environment. Goes from a low, peaks out. It's going to be much flatter, peaks out at about here, I think the 19th hypothesis, and then it starts to flatten out again. And then it's flat like that because the sigma is much larger. It's 50% larger. We also created a key in order to access each one of these probabilities of the hypothesis given data. And that is simple concatenation of the mu and the sigma. This makes for a unique key. And we use that key in order to take the stacked results of probability of hypothesis given data, all 22, 11 stacked on 11, and put them side by side using the index of PRHD. Remember, we always name our ranges. And then we strap together the 4.52 here with the 1. You can see that'll be equal to the key, logically equal. Are they logically equal? True. That'll be coming up true, or 1. And then we look at the row with match in the array called key, which is this whole array in AA. We want a exact match. We have no columns to worry about, and we come up with this. And then these are either or situations. So either or means, and they're independent, MECE, mutually exclusive, completely exhaustive. Okay, is the idea here. Both situations. Well, we add up those probabilities. We can also take the probability here of mu, okay, and of course every time we change this we resample, and accumulate it into a cumulative probability. distribution. Of course, that has to eventually end up at 1. That's the O guy that we know and love and cherish. So what are we going to do with this? Now, over here, what we're going to do is we're going to do a simulation. And the simulation will have 3 components. One component of the simulation is a simple recalculation of everything that goes on. So we're going to tell our machine to recalculate all of this. And you see, I have an entire array from A to A, F, G, A, all the way to H, okay? I'm going to tell the machine to recalculate any cells in there, any cells. Okay, so it'll do a massive recalculation, and I'm going to call this, go up to formulas, define name. I'm going to call this calculation. Okay, this is the calculation region of the world. And you say, okay. And you check over here. Yep, there it is, calculation. Okay, so that's step 1. Step 2 of our simulation, come over here past H, is to say, what is it that we want to simulate? Well, there's a couple of things we can simulate. I want to simulate the average. I'm going to call that X bar of our sample. That's going to be equal to the average. So I want to check an idea out that I have. Here's our sample. Notice it knows it as sample sales. They're very finish of me. Okay, and I'm also going to divide this by 1,000 for all sorts of good reasons. And I'm also going to compute the sample standard deviation. Sample sales, double A. And that too, I'm also going to divide by 1,000 to make it consistent with everything else. And finally, I'm going to do the find the max mu. Okay, now the max mu will be the mu from that maximizes the probability. The most plausible mu is somewhere over here. And I think we know where it will be. It'll be at the 18% level, or 5.311. Okay, that'll be the max mu. So I'm going to make this formulas, create top, and what is this going to be called? Yep, PR underscore mu. Okay. So I'm going to index PR underscore mu. There, oh, there it pops right up. That's beautiful. And I'm going to match the max of PR underscore mu. Okay. Against mu. And I'm going to say the mu created out of the sample and 0. And that should do it. Now this should not work, right? It says name. The name that it's looking for is mu sample. I don't have that. Matter of fact, I'm going to call this mu underscore sample. Okay. And use this. Now remember, this changes every time our sample changes. Right? The high and the low and the width will all change. So I'm going to also create this. And watch what's going to happen. That name will change. Oh, can't find anything. Okay. NA. See if that, oh, both of those are there. That's there. So it should have found this row, this row, and it should have pulled up this value, and it doesn't. So we need to figure out why that happened. Well, I think you can see why this won't work very well, if at all. First of all, there is no max PR mu inside of mu sample. I actually messed this up. I mixed them up. And okay, this happens to me enough times that I have it in my notes all the time. Don't mix up this. So I'm actually going to index mu sample. Ah, there we go. I'm going to look inside of PR mu for its maximum and report back the row. So this is an example of shooting the trouble. Now this should work. And you can see that that doesn't work there. Okay. And it comes up with 4.99 in this case. Yep, 911, there we go. Comes up with this, and we verify that that is the max. And I just did a little calculation down here off camera. Okay, just to show it's in row 6. Okay, so we have this. Okay, and we are actually going to take this and put it down here as part of the calculation field. Okay, so if we look again at the calculation field, I think we see it's all in there. We need to see that it's all in there. Oh, it is definitely all in there. Yep. All those things will simply be recalculated. Okay, next we do something called an interface field. Get rid of my shining face here. The interface field is going to look pretty much like this calculation down here. It's going to be X bar, max mu. Okay. It's going to pick up each one of these. Notice it's all going to change again. Okay, willingly suspend your disbelief. And these are the things that will be interfaced into the simulation. The interface is important because it allows for the computer to, in a sense, adjust its registers every time it's doing a recalculation. And we're going to do this recalculation. We're going to tell it using Visual Basic for applications. We're going to tell this system to repeat itself and do this 10,000 times. How do you like that? So these will be called the interface, define name, and an interface, of course, means that there's something in between the calculation and the simulation. So what's the simulation going to be? It's going to start here. Okay. And this is the header of the simulation. This is row 0. Yeah, I'm going to fix it up a little bit here. Do this, do this. Oh, I don't want to merge. Right. No, thank you. I just want to do that. I want to center it. But I also want to call it simulation. Yes, we're calling the header simulation. And what's going to happen is it's going to advance and drop in rows of values, recalculated values. For my cursor is going down 10,000. Okay, one more step, and we will have the simulation. We go to developer. A developer needs to be on your tabs. We go to files, options, and customize ribbon. And you can see I have developer here. If I have it unchecked, it goes away. You need to check it and say, okay. Okay, you see it's here now. Visual Basic. I've already loaded in, or will load in, this set of instructions. Okay, in order to do that, and it says command Monte Carlo /click. Yes. All right. In order to do that, I have to add, okay, right click on this sales forecast, do an insert of something called a module. There we go. And paste into this, or type into it, exactly what we want, called sub. It's a subroutine command. It establishes free ranges. You just created those ranges. One was called calculation, one was called interface, one was called simulation, remember? Okay. It doesn't do any screen updating for you. You can set this to true and watch the sausage being made, vegan sausage, of course. And it is also saying do a manual calculation. And we're going to reset this down here to put everything back to normal again, normal calculation and normal upgrading. And what it does is it does a calculation. It forces the spreadsheet for R1, which is the calculation to calculate, and then R2 to calculate again, and R3 to do an offset, which basically advances the row from row 0, and offsets always work at row 0. Row 0 is there, row 1. And do that and repeat this 10,000 times. Okay, so now we have all of the pieces in place. We go back to our regularly scheduled program, that is to say our spreadsheet here. Oh, that's the wrong spreadsheet. That's an example of another one we could build. All right, and there is the right spreadsheet. Okay, So how do we do this? Well, we probably need to put a button in here or something just to press it. Don't press this button. And where can we get buttons? Something over here. Say insert. And we want a form control. See, that very first one is exactly what we want. And it allows us to make it of any size. I don't know what I just did there. Let me try that again. Oh, I have a button here. Right click this and assign macro. Now I have a macro here from another program, but I want it from our program. There it is. Say OK. And this is button number 9. That's interesting. Click. Simulate. Okay, if I hit it like this on the right and expand this tab, there's a nice big button for us. Now it's active, which means you see the little hand go over there. Let's see if this thing even works. Nope, doesn't work. It's looking for something that doesn't exist. So we need to debug it. Oh, it's calculation. How come calculation doesn't exist? Well, again, we need to be sure that calculation does exist. And it does seem to exist. And here it is. Okay. And we can edit this, of course. And we have way too many things in here from. My gosh, where are all these things from? So it's gotten confused by something. It just brought in an awful lot of other things for whatever reason. And we will have to go through and tidy all of this up in order to make this work. But calculation is right here. It says it's analysis A1 AH29. Okay. Close. It's called calutation. Aha. And there's the problem. Couldn't find it because it got misspelled. Now this will happen to you. Happens to me. It happened to me right now. We're going to call this properly CALCULATION. And as we fumble through this and make mistakes, we learn from those mistakes. There we go. Now, will this work? I don't know yet. And this is now probably going to work properly. Let's check it out. And if it does, we'll say hallelujah and be very happy. What I have to do with the probably do something else over here. Oh yeah, I have to reset this. Notice it's trying to debug it, tell us where the problems are. So when I pressed it, nothing happened. Okay, so do a continue. Okay, you see the little light goes away. Go back to our original thing here, and it's now running it. We hope. And there they are. Oh, and a little message came up. Congratulations. And now we have 10,000 simulations. You don't believe it? Go to the bottom. There we go. Row 10,004. What are we going to do with these? We're going to put them in bins and look at their distributions. Okay, that will be our next job. And I hope you stay tuned for that piece of the action. There we go, fix those up nicely. And we're going to look at the distribution of the means, the standard deviations, but also those maximum plausible things. Let's say look a lot like what's over here. Huh. They're almost exactly the same. Huh. Yes, huh. We're going to be proving something that people spent a lot of time doing so in mathematical statistics using calculus. Anyways, thanks for hacking our way through this with me. I hope you learned something from the hack and the foibles of misspelling, potential miscalculations, and even debugging a VBA program. Simple program, right? Simple program. But I hope you learned something from that. I know I do every time I do this. Thank you very much for your kind attention, and see you in part 5, where we actually visualize this. Okay, this is the cliffhanger of the story. Take care. Bye.